So linear regression assumes that you have a single interval level response variable. So right there, what does that tell you? Can categorical data be used in a linear regression model? So if you have data that is yes or no, that's an outcome variable, like a binary, you have a very specific type of regression, and that's called logistic regression. But if you're doing linear regression, you need to have interval level response variables. And typically your explanatory variables are also interval scaled. However, you might find yourself in a situation in which your categorical data can be helpful in your multiple linear regression analysis. So for instance, you were trying to discover if eye color has any kind of relationship with the student's overall grade in a class. So if I go with blue, green, or brown, I would actually create 3 new columns of variables. Depending on what eye color the student has is where you would get a 1, and then you would get zeros in the other columns. So really that's the big idea behind creating indicator or dummy variables. And so you need to know ahead of time if you're going to make these variables, because oftentimes your data is not going to come to you this way. And so that kind of goes back to your concept of the design of the data in the data cleansing process of your project. So here we have an example where we're looking at the weight of a model as a function of height. And we're talking about a model as in like a model person. And so height here is an interval variable, and we have gender, which is a binary variable. So your options are going to be to prepare separate models for males or females, or you can recode gender. I recommend when you're coding stuff into dummy variables, it's a lot better to stick with zeros and ones. Because when you're putting, you got to be careful when you're putting numeric values on data, that if the data is not quantitative, that by the addition of the numerical values, you're not confusing that and now imposing a numerical value on that. So be very careful of that. So if you record your columns to ones and zeros, where 1 indicates female, you would have a situation where you're still making 2 models behind the scenes. But remember, when you're looking at the individual slope values, you're going to be comparing that slope to 0. So in this case, the gender slope would be comparing the female slope to 0, which would be the 0 is coming from that male slope for the model as this mathematical model is currently set up. So indicator variables are a very special type of qualitative variable. So qualitative variables can be coded numerically, but the numbers are only there to place the observations into different groups and doesn't play a role in that regression algorithm itself. An indicator variable, also known as a dummy variable, each level of the qualitative variables is put into separate variables, where 1 indicates that the trait is present and a 0 indicates that the trait is missing for that observation. So here we have an example where I'm looking at the life of a cutting tool based on the tool used. And so I set up my regression model with separate slope values for each of the levels that I'm looking at. And if we look at this model algebraically, we can see that when we look at one of the tool types, the x value for the other tool type is going to drop out because it's 0. And another thing to keep in mind is, if we're plotting the line for both models, we can see, sometimes we have the same slope, but different y-intercept values. And with dummy variables, ultimately the slope of each predictor variable is going to be compared to the slope of 0. So if you need to have one of the levels as baseline as comparison. So that means that when you're preparing a multiple linear regression model, you're going to include one dummy variable less than the number of levels in your categories. So here we have the examples where we have 3 tool types, A, B, and C. So when we include that in the model, we're only going to include tool type A and tool type B, because both of those slopes are going to be compared to tool type C, because we dropped that out of our model. We're using that as our baseline for our starting point for comparison. So when we're looking at the general concepts of indicator variables, fundamentally what's going on with the models that include dummy variables is that you're pulling tool models to find the best fit of the data. Because one model is more useful to work with than separate models for each level of our variable. So if we expect that the slopes are going to be different for our two different variables, we can use our dummy variables again, but in this case, we would have the equation shown below for our model. And continuing with our tool example, if we're looking at a difference in slopes, we can see that both the intercept and the slope are going to change as we shift from one tool to the next. So when we look at the graph, we can definitely see that these two lines are no longer parallel, and they do have different y-intercept values. So in this case, we do what's called an F-test to test the hypothesis that the slopes are not equal, or they are equal either way. And so our HO, our null hypothesis, is that they're equal or they're not statistically different from 0. And our alternate hypothesis is going to be that one of my slopes is not equal to 0, or one of my slopes doesn't equal the other ones. And so when I'm testing this hypothesis, I want my F value to be large, which will cause the corresponding P value to be smaller, right? And so when the F value is large, this is showing my sum of squares residual. When this value is really, really big, giving me a smaller p-value, this is telling me that my groups are more different as my F statistic gets even bigger. And so to get to statistical significance is when you take that F test and you look at the table to find out what your corresponding p-value is. And that p-value is looking at the probability that you're going to classify it wrong. So if you have a p-value or an alpha value of 0.05, you are saying that you have a 5% chance that you're basically wrong. Okay. So going back to our tool life data, this is what our output and fitted regression model would look like for this particular data set. So going on to another example, we're looking at the size of a home and the type of air conditioning. And in this case, we have 4 levels for our type of air conditioning. And so here we see our regression model overall, and then we see it set up for our individual 4 models that we have. So since we have 4 levels of predictive dummy variables or indicator variables, we're essentially pulling the results from 4 models together on this. And so, in this example, it'd be unreasonable to assume that the different air conditioning methods all have the same amount of pull on energy. And so we also need to consider the size of the home as an interaction term between the size of the house and the type of air conditioning system. So when we do that, we also need to kind of keep that in mind. But, we still are separating these 4 individual units for our overall pooled model from our dummy variables. And so if we added an additional qualitative factor of weather to the model, we could then introduce an additional dummy variable. So going back to this tool example that we've been working with, we can also consider the effect of the viscosity of the oil as a separate indicator variable. And so with the tool, the addition of the viscosity of the oil as a second indicator or dummy variable, we need to consider as well as the interactions with the tool type and our tool type, giving us the regression equation that we see here, with the implication that there are 4 combinations of tool type and oil viscosity. So in summary, when you're using indicator or dummy variables, if your software allows for you to keep your categorical variables as text, such as R or SAS, please do so, because it helps you to avoid adding a numerical interpretation to data that is not doesn't have a numerical meaning. So that would end up giving you an inappropriate interpretation of your data. But, you know, these indicator variables, dummy variables, can be very useful to group large portions of observations together in your analysis. So, for example, if I want to say this person's above or below 65, we can do that. But the biggest drawback with using dummy variables is that information loss that we get from recoding our data.